Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by our friends at Rollbar. Check them out at rollbar.com/changelog. Move fast and fix things like we do here at Changelog. Catch your errors before your users do with Rollbar. If you're not using Rollbar yet or you haven't tried it yet, they have a special offer for you. Go to rollbar.com/changelog. Sign up and integrate Rollbar to get $100 to donate to open source projects via Open Collective. Once again, rollbar.com/changelog. Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Thursdays at 1 p.m. Eastern, 10 a.m. Pacific at changelog.com/live. Join the community and Slack with us in real time during the show at changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
G'day, you're listening to JS Party. This is another episode where we consider JavaScript to be a party. Thank you so much for joining us. We actually have some really exciting stuff to talk about this particular episode. We have our regular panelist, Nick. It's great to see you.
Yeah, good seeing you too.
And we have a very special guest joining us today to talk about a very exciting topic, machine learning. I'm very excited to welcome Paige Bailey.
Hey friends! Hello! Delighted to be here and to talk to y'all about JavaScript and about TensorFlow.js.
So Paige, you currently work at Google and you're a senior technical advocate for TensorFlow, is that right?
Yep, I am on the DevRel team for TensorFlow, which is embedded within our research and machine intelligence org. So Google has a whole bunch of developer advocates. You probably follow a lot of them on Twitter, whatever your favorite flavor of social media is. But our org is a little bit different in that it's embedded outside of cloud and right with the TensorFlow team. So it's kind of rad that I can, if something's broke, I can literally look over my desk and yell at somebody to fix it. So it's kind of awesome. Yep.
That sounds very cool. So we're going to back up a little bit because I know that in the JavaScript community, some of us will have heard of just the term TensorFlow or the actual tool, but not everybody knows what it is. So what exactly is TensorFlow? That's Nick. Nick's definitely interested in finding this out too. So how does TensorFlow fit into machine learning and what exactly is it?
Awesome. So TensorFlow is a library intended for numerical computation of all sorts. So it's not just for deep learning. You can also do a sort of traditional machine learning. So if you have familiarity with things like decision trees or random forests or boosted trees or support vector machines or logistic regression, all that stuff is supported with TensorFlow as well. So just think of it as like a numerical computing library. If you have experience using Python, you might have used something called NumPy before. And TensorFlow can kind of be almost used as a replacement for NumPy. But what it's intended to be is a collection of tools, a sort of very expansive API that gives you the ability to do these complex numerical tasks in a more straightforward way that can also scale. So not just on small amounts of data, but on any sort of data size that you have available and on a variety of data types. So everything from text to CSV files, to video, to audio, to pictures, all sorts of stuff. And TensorFlow got a whole bunch of press in around 2015 when it was first released. Because it was it created this really first robust end-to-end machine learning framework for doing these complex deep neural nets. And it had been used at Google historically for years and years under a different name. But Jeff Dean, who's kind of a baller, was like, "Hey man, we're gonna open the." It's true. He was kind of like, "Hey man, we're gonna open source this." And then they did. and they've just been open sourcing more and more of it since then. So that is kind of a long-winded example to what TensorFlow is. The TLDR version is it's tools that help you do predictive models and also any sort of complex numerical computation, usually with Python, but it's grown to be a collection of languages, lots and lots of additional products. So now we have Swift for TensorFlow, we have TensorFlow.js, we have TensorFlow Lite if you want to put TensorFlow in a phone, we have TensorFlow Extended if you want to build these end-to-end machine learning pipelines. We have, we've got TensorBoard to visualize machine learning. We've got JAX and XLA. And the last time I checked, there were 77 sub-projects under the TensorFlow organization repo in GitHub. So it's a big honkin' thing. But also, what question, does that help clarify it a little bit? Or should I give tangible examples of stuff you can do with TensorFlow?
So I'm obviously very new to machine learning and looking into all of this, but when I look for YouTube videos and such, and the topic of machine learning comes up, maybe I'm just drawn to the cool name, but neural networks is the thing that comes to mind. So is TensorFlow a way to build neural networks, or is neural networks just a generic term for all of the computational things that you can do with TensorFlow, or what's the relationship between those two?
That's a great question. And so neural networks are one kind of algorithm or one kind of sort of implementation that you can have for machine learning models. TensorFlow certainly helps you build those. And with the sort of newer versions of TensorFlow, since Keras, which is a high-level API, has been embedded, you can build complex neural networks, train them, fit them, use them to predict things with less than 10 lines of code of Python. And the same goes for TensorFlow.js. You can build complex neural network architectures capable of analyzing, billions of images or very sort of massive input data without having to think too hard about it. That's kind of the idea, is that you shouldn't have to have a PhD in machine learning. You shouldn't have to understand, the intricacies of linear algebra and sort of ordinary differential equations and all the rest of it to be able to implement a neural network.
Can I ask, what is the hello world of a neural network, or what's the hello world that you would normally do in TensorFlow when you're first getting started?
So the hello world of TensorFlow is probably the MNIST example. And MNIST is, if you've been doing machine learning, it is horrifically painful because the data set is used everywhere. But it's basically, it's being able to take in images of integers, so handwritten digits from 0 to 9, and being able to classify them as to what digit they actually are. And I am going in the changelog Slack channel. I am going to put in the code, in the Python code, that is sort of all that you would need to do in order to implement that model. It really is just a few lines. And what it's doing, if you take a look at the chat window, is that you import the TensorFlow library, you import the data set, you divide it into training and testing. So you would take a portion of your data to build a model off of, and then you would hold out a little bit to make sure that whatever prediction you made was accurate. So data that your model hadn't seen before, so it couldn't cheat, Then you would build out a model, and here we have a dense layer, a dropout layer, and another dense layer. You would compile it with a loss function called sparse categorical cross entropy and an optimizer called the atom optimizer. There are lots of different kinds for losses and optimizers, and you can have a lot of different metrics that you would care about. But those are just the ones that you would use there. You run model.fit and say how many epochs you want, how many times you want to cycle completely through the data. And then you would use model.evaluate to get the answer of how right or how wrong you are. But that's all it is, right? And all machine learning models and all machine learning projects really follow that same pattern, in that you have training data, you have test data, you build some sort of model architecture, you run it on your training data, and then you test how accurate that you were. And the intro to words that are used in TensorFlow glossary. I love it. Yes. So we have a thing at Google called the Machine Learning Crash Course. And we have a machine learning glossary associated with the Machine Learning Crash Course. And it is also a lot of words, but the words are explained. And you actually end up with some terms that are kind of cool, like crash blossom. Like Crash Blossom should totally be the name of a band. But what it means is that it's a sentence or phrase with an ambiguous meaning. So you see those a lot in newspaper headlines. So I think that the version that they mention on the website is red tape holds up skyscraper, because it's like, wait, what? What does that actually mean? But I love it, and they cause a lot of problems in natural language understanding tasks because ambiguous meanings.
This is a Hello World example, but it's actually been applied to lots of different real world cases for like at least a decade or two, right? Like, for example, recognizing handwritten numbers is very useful when you're trying to cash a check by taking a photo of the check, right? Is that sort of what that would be used for?
Absolutely, you are spot on. And also, I think the first use case that it was used for was back in the 90s. So whenever the U.S. Postal Service, whenever people still sent mail, they would use it to detect the zip codes on envelopes and automatically sort them based on that. So it's a very it's sort of a very useful application. And that everybody loves being able to automatically transcribe something that they take a picture of. But it's also straightforward in that less than 10 lines of code to do a thing. And so for that last layer, you might notice that it says activation equals tf.nn.softmax, and then there's also a 10 there, and what the 10 means is that you have 10 different options for things that it could classify. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then softmax just means that it would be a classification problem. So you're picking one of those 10 things as opposed to giving a numeric value like 9.2 or 12.5 as an estimate.
So this Hello World example with TensorFlow, is this specifically a neural network?
That is a neural network, yeah. It is.
Okay.
It's using the higher level API that I was telling you about before. It's Keras,
Yeah.
and that's one example of a neural network. And let me also link the tutorials page.
So I actually watched a video on this beforehand as kind of research on this specific problem, and I think that this is actually doing the same thing because I see 28 by 28 in there for input shape, and I'm assuming that that's the pixels of the image that you're trying to classify.
Yep, you are 100% spot on.
Yeah, so it's turning that into just like an array of pixel values for zeros or ones or values that represent whether the pixel is colored or not, and then it's taking that from I forgot how many that is. Is it 7? I can't remember exactly how many are in a 28 by 28 array, but taking that and then boiling it down to a number 0 through 9.
Yep. And the mentality behind so kind of the idea behind Keras and behind the super high level APIs is that developers, so if you're building a web application and you want to be able to do image classification, or if you want to be able to do text classification or something of that nature, you shouldn't have to, I mean, it's cool to understand the internals of a neural network and to understand that when you select this particular kind of loss, it's applying this sort of transformation. Or if you select an atom optimizer, it's putting this much tweaking the numbers and turning the knobs and dials in this way in order to help better predict whatever value that you're trying to. But the idea is that if you're a web application developer, you shouldn't have to know all of the internals of how a neural network works in order to deploy a model to production. It's good to know, and it's especially good to know about the ethics of models and about how data can influence model decisions. But in terms of having to know the linear algebra, that shouldn't be a prerequisite for being able to do cool things with machine learning.
You mentioned web developers, and you mentioned also before that TensorFlow.js is a thing. Theoretically, is this just me running a library called TensorFlow.js in the browser, and then would I be able to actually load something like a model that is doing like the MNIST data set to figure out what the handwritten number is? Is that something that you could practically run in a browser, and is the browser powerful enough to do that?
Oh yeah, absolutely. So yes, the browser is 100% powerful enough to run TensorFlow.js. And they also recently released node bindings. So that allows the same JavaScript code to work in both the browser and Node.js while binding to the underlying C implementation. So that's pretty rad. And there's also so being able to use the GPU that you have in your laptop to train. Even though you're running and sort of creating this model in the browser, is really, really nifty. The other so does that kind of answer the question? You can do a lot of really interesting. Most of my favorite TensorFlow examples actually are all created with TensorFlow.js. So you can do pose detection in the browser. So if you're standing in front of your webcam and you're sort of flailing your arms around or, doing a jumping jack or something, it's able to detect sort of where your limbs happen to be. It's able to do eye tracking, able to do kind of sort of basic sort of object segmentation, so it's able to detect that I'm a human and draw a little line around me. It's able to there's this guy named Tiro. Let me also put a link to his work. His handle on CodePen is Tiropa, but he does the most awesome code pens for sort of experimental drum machines using neural networks and sort of manipulating harmonics using deep learning. So the idea is that you can create a melody with a guitar and then automatically have a drum accompaniment or like a bass accompaniment created for you. Or it's really I'm enchanted by the sort of creativity that folks have been showing with the TensorFlow.js examples.
These examples, are they using a pre-trained model and then just applying that in real time in JS?
Yes. So I think the examples that you're playing with on the website, they're using a pre-trained model, but you would also be able to train your own models in the browser if you wanted to. And to be able to do, if you wanted to do object detection on sort of custom images or custom entities, you could use transfer learning on top of the existing model to sort of make those modifications. And I love the post detection. That's interesting.
Would there be a time that you would train something in the browser and a time that you would not train stuff in the browser? Like, is there sort of performance considerations to take into account when deciding whether or not you actually need to train something in the TensorFlow.js environment?
That is a great question. I personally, I prefer. Let me backtrack. So if you have a very, very large model, you should probably be training it using TensorFlow Core and then exporting it as a saved model to TensorFlow.js. And all the sort of keras, the friendly, 10 lines of code syntax that I showed you before, that works to export as a saved model. If you have a small sort of machine learning problem, it's fine to train it in TensorFlow.js. You might not see as high of accuracy as you would expect from a TensorFlow core model, but it'll still be good enough to solve the task. And then also the slowness factor. So if you train in a browser using TensorFlow.js, it'll probably be a bit slower to train than if you use TensorFlow core, and especially for large scale models. So the small scale stuff, it'll still train in a reasonable amount of time. The large scale stuff, it might be 10 to 15 times slower. And I think that there's a benchmark on the website as well to kind of give an idea. Yeah, let me send a link over to that guide. But yeah, so the idea is that for the most part, you can train lots of models using TensorFlow.js. They're creating a models repo. So let me pull up the link for that guy as well. But the idea for that is sort of a model garden where, again, you don't have to know everything in the world about neural networks and machine learning in order to implement and to use the things that researchers have created. So that link right there is a link to TF.js models on GitHub. And you can see MobileNet, so classifying images with labels, PoseNet, so the real-time pose detection that you can see in the browser, object detection, speech commands, k-nearest neighbors, and they're growing out this repo pretty substantially and very, very quickly. So you can use off-the-shelf, state-of-the-art models without having to understand the machine learning internals.
That's really cool. So I can just pick a model based on the problem I want, whether it's trying to detect like speech, like translating speech, or trying to find like edges of things, or digits, like in that example. Is there a way to take a pre-made model like this and manipulate it a little bit to change it for a slightly different problem set?
Yes, and that's something called transfer learning.
Okay.
What transfer learning does is it takes a model that's been trained on a sort of a large scale data set, or maybe with some very powerful architecture over a long period of time. It takes the insight that was gained from that model, and then it adds a couple of additional layers to the top to say, so for example, the image detection model, it can detect a lot of different entities out of the box. So it can detect dogs, it can detect cats, it can detect, coffee mugs potentially, and people. But if you wanted it to recognize specific people or specific kinds of dogs, so to say, like, this is a Chihuahua and that is a Dachshund and that is a Boston Terrier, you would be able to build off all of the information that the model's already learned about, like, oh yeah, that's a dog. Provide like maybe 5 to 10 examples of what a Boston Terrier looks like, and 5 to 10 examples of what a Chihuahua looks like, and 5 to 10 examples of what, whatever your favorite breed of dog is. And then that model would be able to retrain. It wouldn't take nearly as long because you would have much less data, and it would have this entire big, long history of things it's already learned to pull from. But it would be able to understand, okay, I see an image, and that is a Chihuahua, and that is a Boston Terrier, and that is, whatever, for that task. And that was an image example, but it works the same way for text, though text is a little bit trickier to apply in multiple domains, to video and to audio.
I actually think that I've done this with audio now that I think of it.
Yep. What use case?
Yeah, so on my Twitch stream, I wanted to have automated closed captions because, I couldn't pull together a budget to have like live human-made captions. And so I took like a regular American English conversational model, and then I trained, like I sort of like created a data set of my own speaking the words that I was saying on my Twitch stream, obviously my accent and any background noise. Mm-hmm. And I used that along with some subtitle files in order to sort of try and generate an additional layer on top to make it slightly more accurate. Is that the same as what you just said?
Absolutely. That's transfer learning. And it's learning. So it's taking all of the information that it's used to understand English from a variety of different speakers, and then it's sort of specially tuning to your voice. So it already understands what specific words are, and now it understands what those words sound like when Sue says them. So yeah, you use transfer learning. Congratulations.
Yay!
Yay!
It did actually push the accuracy up. It didn't push it up enough for me. Like it was still 1 in 10 words is wrong, which sounds really great, but it does sort of go on a weird chain if one word is wrong, for example. But it was really exciting to see that works and that I didn't have to do the hard work of having to create that existing model in the first place, which is really cool.
Yep, and having to source all of the data, that's the other big thing. Like, because to train models to really high accuracies, you need a massive amount of data and also really, really high-powered really high-powered hardware. So, clusters of GPUs or things like TPUs or if you wanted to kind of roll your own in Verilog, you could use an FPGA. But sort of those high-end architectures that are also pretty pricey. And a lot of people, myself included, I don't have access to massive amounts of data, so being able to take the models that other folks have created and to build off them with my much smaller data sets, but still achieve high accuracy, it's pretty nifty.
This episode is brought to you by Raygun, who just launched their APM service. It was built with the developer and DevOps in mind. They're leading with first-class support for .NET apps, also available as an Azure app service, and have plans to support .NET Core, followed by Java and Ruby in the near future. After doing a ton of competitive research between the current APM providers, where Raygun APM excels is the level of detail they're surfacing. New Relic and App Dynamics, for example, are more business-oriented, where Raygun has been built for developers and DevOps. The level of detail provided in the traces are amazing, the flame charts are awesome, and allows you to actively solve problems and dramatically boost your team's efficiency when diagnosing problems. Deep dive into root cause with automatic links back to source for an unbeatable issue resolution workflow. Learn more and get started at raygun.com/APM. Once again, raygun.com/APM.
So we talked about the fact that you can run models and also train models in the browser, but one thing that we sort of haven't really touched on is why are we trying to do this in the browser itself? Like, what kind of advantages does that give us?
That's a great question. And I think one of the reasons that TensorFlow.js started was because not everybody has access to high-end computational power. Browsers are kind of ubiquitous, right? If you want to hit everybody, you probably would want to implement it in the browser, as opposed to, making somebody use Python or making somebody use something like C++. So having machine learning in the browser was a natural choice, and that it's where you can impact the most developers and sort of give them the tools to create these impactful projects. Another reason, I think, is because you have so many additional sort of like webcams, right? Like being able to use PoseNet or object detection from the webcam on your laptop. That's also an amazing tool, and being able to open up a browser from a phone is also pretty rad. So that was kind of the motivation, is we want to do machine learning for everybody. If we're wanting to do it for everybody, it can't just be Python. Let's put it in the browser too.
That's really cool.
Mm-hmm.
If it can be written in JavaScript, it eventually will be.
Skynet's going to be written in JavaScript, right? Like that's the thing.
We touched on this a little bit at the break, but could you maybe summarize what some production examples of TensorFlow might be?
Oh, absolutely. And this is one of my favorite topics. Is machine learning sounds great, but I don't really care about hot dog, not hot dog, or I don't really think that I don't think that there's a use case for determining if something has a cat or not. Like that seems kind of silly. And I agree 100%. But some tangible use cases that you could have, for example, would be, imagine how cool it would be is if you were typing an email, and you were typing a sentence that might be taken offensively, without sort of recognizing it, because it's the middle of the day, you haven't had enough coffee, maybe, like it's everybody feels kind of stressed at work. Think about how cool it would be if you had an automatic sort of typo looking suggestion pop up saying, hey, like this term might be taken in a bad way. Maybe try these other words instead that might be a little bit less aggressive. Or maybe, this sentence could be taken multiple ways. Maybe you should include an emoji to make sure that folks know that you're not being angry. You're just being playful or something of that nature. Another great use case is so Amazon, whenever it makes recommendations of what products you should buy, or Netflix, whenever it makes recommendations that, hey, you should watch Black Mirror, it's because it's looking at all of the other viewing patterns of people similar to you, analyzing all of them, doing something called market basket analysis, and then or matrix factorization even. Because market basket analysis is kind of computationally intensive, but that's a rabbit hole. So just think of it as it's looking at a lot of people who have interests similar to yours, and it's saying, well, Jane, who also liked A, B, and C, watched D, so maybe Suze would also like D. So that's another example. The other use case that we talk about a lot at Google is a mobile application that's able to detect sort of diseases in plants. This is being used in Africa, where Wi-Fi connectivity is kind of spotty. So the model's actually been exported, so it doesn't have to rely on internet connectivity. And farmers, they can take a picture of a plant leaf, and based on a corpus of data that it's been trained against, the model can tell them what kind of disease that plant leaf has, and then also how they would go about treating it. So those kinds of specific use cases. I feel like the machine learning community latches on to some of the more playful aspects and the more fun examples. But in reality, there are so many impactful ways that machine learning can help businesses. And they aren't quite as sexy as, the Silicon Valley examples, but they are really cool. And TensorFlow.js and TensorFlow are more than capable of taking care of any machine learning task.
That's really cool. And given that this is being used in production, and it's becoming really, really popular, of course, another big topic in machine learning too is things like machine learning ethics and like how where the data is actually coming from to train these models and things like that. And then you even look at things like adversarial machine sort of learning attacks as well. And so I wanted to leave enough time to talk about that as well, just so that people are aware of some of the gotchas to look out for. But let's sort of talk about maybe first some of the more foundational parts of machine learning ethics and data sources and things like that. Can you sort of introduce us to where machine learning can sometimes go wrong?
Absolutely. So I'm also going to, I hope Slack supports GIFs. So let me put that in there. But this is something called TensorFlow model analysis. Oh man, it didn't do it. Gosh dang. So let me put the link there, and then also the link to the GitHub repo. So there's that, and the what if tool as well. So machine learning models, they're only as good as the data that you put into them. That is not a debatable topic, right? It's like if you have a child that you're teaching how to recognize squares and triangles and circles and all the rest of it. If you haven't been teaching the child what a circle looks like, there's no way that he or she would be able to understand that shape. Or say you're talking about dogs in a country that only has like 5 particular breeds, and you go to a different country that has a dog, and that's not one of those 5 breeds, you probably wouldn't be able to accurately classify it because you had never seen that data before. That's kind of a fumbled example of your data is incredibly impactful. And what you see whenever you have data that's biased being used to create machine learning models is that groups that are marginalized or groups that are excluded from the data set or included in the data set, but in a negative way, just have those stereotypes perpetuated. And what does that mean? And a lot of people have heard about the so there's a test that incarcerated individuals take towards the end of their prison sentence that determines whether or not they would be eligible for parole. And this test includes a lot of questions like, was anybody in your family also incarcerated? Or were your parents divorced? Or did you go to college? Or a lot of questions that really have nothing to do with the person themselves, and are completely out of control of the person. Like, you don't have any control over whether or not your parents get divorced. You don't have any control over whether or not people in your family have gone to prison. And those questions, they negatively impact people in already marginalized groups, so people of color, and people who come from lower economic backgrounds. And what they found is that this test was preferentially granting early release of prison or early parole to white males who came from, sort of wealthier backgrounds, and it was negatively impacting men of color who came from impoverished backgrounds. And that was entirely due to the fact that the machine learning model that was created to predict whether or not people would have recidivism, whether or not they would start doing crime, was being built on this corpus of data that was sort of pointing towards men of color being especially likely to do that, when that is not the case at all. So building models on data that is already biased means that you're going to have a biased model. And it's really difficult to sort of understand where some of those biases could arise in data, which is why we have built tools as part of TensorFlow to help understand data sets and to spot those nuanced differences in features. So here you have 2 links. One is the model analysis tool, and the other one is the what if tool from our Google research entity called PAIR, which is People in AI Research. And what it does is it sort of guides you towards questions that would be useful to ask as you're creating your model. To say like, well, if we look at the distributions for marginalized groups, what does this mean? And also it helps spot related feature types. So for example, zip code and race are very commonly related. And that might not necessarily be straightforward if you didn't have experience working with census data. Does that make sense?
It does. And I'm really glad that there are these frameworks coming out for you to ask those questions. And I even remember referring to one of your resources that you made, I think at least a year ago, which was very helpful for me to understand where things can go wrong.
Yeah, the one from our open site. I can link to that as well. But it's just helping because nobody, if you're a researcher, nobody ever wants to hurt anybody, right? Like assume no harm should be kind of the first thought for all of us. And it's just that if people aren't given insight into the questions that they should be asking, it's really hard for them to understand where things could go wrong. And so the resource that Suze's mentioning was a collection of questions that can be asked throughout the entire model building process about where is your data sourced, how is it refreshed, how are you intending to keep it up to date, what would be one of the ways that the ethical machine learning vignette, and it was for our uncomp. But it was very, very focused on spotting and preventing proxy biases in machine learning. And I used the example of race and zip code when predicting loans.
Very cool. And we'll make sure to provide all of these in the show notes for the episode. And it makes me wonder if we can eventually get meta with this kind of problem, because there's, as you mentioned, there's so many problems out there that are already using machine learning to figure out what I want to buy next on Amazon or watch next on Netflix or whatever. But then all of these models that might have been created that do have these biases in them. I'm wondering if machine learning can help you predict if your model is going to have bias eventually.
Yeah, I would love to see that, or at least kind of being able to better understand data sources and to be able to spot when you might have unintentional bias in your data. That's a great idea.
And just on that topic, if you're sort of not really in the machine learning field and you're actually trying to choose a model to use for yourself, but you don't have a lot of that background knowledge, is there any way, given that models can really be a black box, is there any way for you to be able to somehow judge if it's going to be a model that isn't biased in negative ways? Like what kind of questions can you ask yourself when you're on that side and you're not actually the person developing the model?
Gotcha. So it's always really hard to understand what data goes into a model if you don't have sort of direct influence on that model's creation process. But there are tools. So I'm thinking in particular of TensorBoard, which is, let me put a link to that guy as well, and then also a link to the TensorBoard GIF, which is probably the best description of it. That allows you to look at model architectures and to understand sort of what decisions are being made, where and when. So, for example, one study that was done a while back, it's kind of notorious in the machine learning community, is that they had a collection of photos of people, so just portrait photos of folks. They and the research question was something to the effect of, can I detect whether or not this person is gay or has like not of a binary sex, that sort of thing, detecting whether or not a person was gay based solely on a photo. which is ridiculous. Like that is the silliest or one of the silliest research questions that I have ever heard in my entire life. But an academic published a paper saying that, yes, absolutely they could. And here's how with machine learning. And so a group of researchers at Stanford challenged that assertion and said, like, I don't think that you were able to accurately gauge whether or not a person is gay based on a photo. And they found by highlighting the pixels that were being used to make those assessments during the machine learning process, that what the model was picking up on wasn't, anything about the human themselves. It was detecting piercings on the face. So people with alternative sexualities, or people who prefer it's for whatever reason the sourced images had preferentially more piercings than people who were heterosexual, and the model was picking up on that. So it would detect a piercing, and it was using that as a proxy to say this person is gay, which again is ridiculous. And then there was the other aspect that often the photos of people who are gay were taken from kind of a different perspective. So from, like looking up into the camera as opposed to looking straight on. And that was also being picked up by the machine learning model and has nothing to do with the person themselves, just the sort of way that the photo was taken. And it's very sort of unnerving to think that was a paper that was published, peer reviewed before published, and that nobody challenged throughout that process.
Oh, that's crazy.
Yeah, and I can hunt down a link for the PDF of that guy as well. But it was awful. And I see a question from David: AI leading to inadvertent discrimination is really interesting. And that is 100% true. Tiny input differences do have massively different outputs over time. And the other thing is that if the models aren't kind of checked and QC'd, they just perpetuate the bad assessments that they were making before. You know what I mean? So like they will preferentially not give loans to people of color who come from low economic backgrounds, or they will preferentially not allow people of color to have to be able to be up for parole in a reasonable amount of time. Unless you are actively asking questions to challenge the model's assessments. And as an industry, I think that it's on all of us, if you're doing anything with machine learning, to ask these questions. If something smells fishy, like it doesn't matter if you have a PhD. If it sounds like it might be wrong, a model assessment might be wrong or biased in some way, absolutely challenge the data science team that's being used to create it. But we do have, so the entity that I was mentioning before, PAIR at Google, is People in AI Research. And it's a human-centered research and design initiative to make AI partnerships fair and to make sure that we have tools that will be able to help spot these biases. And TensorBoard's one of them. The What If tool is one of them. Sort of the visualizations that happen through this publication called distill.pub, and that's supposed to be a link, but I guess it didn't go. But it's sort of this beautiful publication that goes into what is actually happening whenever a machine learning model makes its assessment, and how can we really understand the mathematics behind it, because it's so dang complicated. It's more complicated than a human could possibly understand. But how can we shine a light onto these decisions?
This is great. And I wanted to also throw in a couple of recommendations for myself. If you're trying to sort of understand this topic at a higher level, I found that 2 books that really helped me was Technically Wrong and also Weapons of Math Destruction, which is a really clever it's a really clever title, but it's also very, very helpful. So if you were looking to sort of get a high level grasp of the topics before sort of diving into some of these more technical resources, then I would definitely recommend those 2 books.
Absolutely. And then there's also an ethics, like a little 1-hour ethics ethics extension to Google's machine learning crash course. 60 minutes, self-paced, and it goes through a lot of biases that you experience in machine learning, but it's also interesting in that those biases are expressed in everyday life as well. So if it can fool a human, it can also fool a model. It's really sort of interesting to see.
This episode of JS Party is brought to you by onemonth.com, one of the best places to learn how to code in just 1 month. Their courses have helped over 60,000 students go from knowing zero about coding to building programs in languages like JavaScript, Python, and Ruby. Onemonth.com graduates have gone on to get jobs at awesome startups like Airbnb, Instagram, and Spotify. Their courses are easy to follow with step-by-step video tutorials, instructor-led with weekly assignments reviewed by your instructor, and results-driven, with each student graduating the course with a portfolio of projects to show prospective employers, as well as a certificate of completion. If you're interested in taking your career to the next level, head to onemonth.com/JSParty and get 10% off any coding course. Once again, that's onemonth.com/JSParty to get 10% off any coding course. A big thank you to onemonth.com for supporting JS Party and online education.
I'm so excited to talk to you about this topic. So, Paige.
I know what you're going to ask, and I'm super jazzed about it.
So, for those who are listening, Paige and I actually used to work together. And one particular topic that I get excited about, that I know that Paige is really excited about, that I couldn't not mention is, Paige, can you talk to us about the topic of adversarial machine learning? Like, what is that? And it does actually tie into the ethics a little bit too from the previous segment.
Absolutely. And I just posted a link in this the Slack channel about a library called Clever Hans, which doesn't get nearly enough love, but which is something that I vitally enjoy. And one of my colleagues, Ian Goodfellow, is the sort of lead. Think of it as the red team for machine learning. So the red team for security is like, okay, you've built this enchanting ivory tower system. I'm going to see if I can bring it down. And Clever Hans is like the red team for machine learning. Yeah, right. Like, so a question, right? Like, so you have machine learning models. You have this great pipeline where you can input some sort of data and then get back some sort of predictive assessment with some sort of confidence level. So I think that this is a dog with 85% confidence. How would you go about breaking that? And the answer is that it is exceedingly fragile to be able to manipulate these systems in ways that would bring them down kind of catastrophically. So what do I mean by that? There's this great example, and I'll send a link to the paper. It's probably listed on the Clever Hans GitHub as well. But there was a research team that was looking at a classification model for pandas and for gibbons. And gibbons are kind of monkeys. So it was looking at various animal types. And you would have an image that was very clearly a panda. The machine learning model would correctly assess that it was a panda with like pretty good confidence. And then the question was made of well, what if I introduce a small amount of noise into this image? Like, what if I take just random noise, apply it? Here we go. So I found the tweet from, because everything I do, I tweet. It's like and eventually I will be an old lady and I will be delighted because I will have this complete timeline of my life. But there we go. So it has a panda with 57.7% confidence. You introduce a very small amount of random noise to the image. So to a human, it still looks exactly like a panda. It looks exactly the same. But suddenly your neural network thinks that it's a gibbon, a monkey, with 99.3% confidence, just like a massive amount of certainty that this is a gibbon, when in reality it is totally a panda. And you probably also saw the example a while back where you had a turtle that was painted in such a way that that a neural network thought that it was a gun. And there are stickers that can be placed on street signs so that neural networks that are used for self-driving cars might not be able to detect that those are street signs that they should stop at. There are ways that you can sort of put on makeup that make it so that the facial recognition networks don't recognize who you are. It's amazing, and not amazing. It's terrifying and awesome. That these systems have been so optimized for particular tasks that they just break if you show them something that's completely outside of the realm of their experience. I like to talk about overfitting the same way that I talk about learning things in school, right? Like, everybody went to school with the kids that were super great at memorizing stuff. Like, they, you gave them a list of terms, and they were able to spit back out exactly the definition, or if you gave them a math problem that they'd already seen, they were able to sort of regurgitate the answer without thinking too hard about it. But if you showed them something new, so if you gave them something that they had never seen before, a problem that required some sort of creativity, that required them to apply what they had learned previously to a new situation, they just kind of fell into, they weren't able to do it. And that is overfitting a machine learning model, is that it's very, very good at sort of making assessments on data that it's already seen before. And then when you show it something that's just a little bit new, it's unable to sort of generalize to this new situation. So, and yes, the answer, so David, you are 100% spot on. There's always, so imagine if you had a system that was tasked with determining whether or not there would be a missile location in a satellite image. And you had a nefarious actor that was working either internally or externally that decided to manipulate images with random noise in the hopes that it would that your system would think that there was some sort of missile location in a place that wasn't that was completely innocuous, or to be able to obfuscate a missile location from the satellite image itself. But that is, and you also see things like deep fakes, so which is outside the realm of adversarial machine learning, but is also very troubling. The tooling that we build, so again, things like the what if tool, things like model analysis, things like TensorBoard, being able to spot these changes in data, being able to spot images that have been altered in some way. This is going to be huge. And it's, again, all of our responsibility to make sure that we push companies to be doing this work, because it's just so easy for these fragile models to be compromised.
Definitely some good food for thought. Thank you so much for covering that. I don't know about you, but I'm probably not going to sleep as tight tonight thinking about this kind of stuff. But it's really important to share how exciting machine learning is, but obviously the gotchas and the sort of Spider-Man, great power, great responsibility. So really appreciate you being able to talk about such a massive breadth of what machine learning actually involves. This is awesome. Thank you so much.
Yeah,
thank you
very
for
much.
inviting me. Yep, thank you for inviting me. This was fun. And I highly encourage everybody to try out TensorFlow.js. If something breaks, please yell at me on Twitter or yell at me on via email. My address is webpage@google.com, Paige spelled like my name. And also, again, just to reiterate, you don't have to have a PhD to challenge what a model is assessing. If something doesn't strike you as being particularly fair, or if something strikes you as being biased, definitely speak up, and sort of make those concerns known. Because it's all of our responsibility to sort of be the watchman for this stuff. And it's a huge I have huge optimism for what machine learning can do for society and for businesses and for people, but also a very healthy respect for how much it's going to take all of us working together to make sure that reality is the reality that happens.
Oh, Paige, that was the perfect last sentence to take us out. Thanks. I'm going to stop it right there.
All right, thank you for tuning in to JS Party this week. Tune in live on Thursdays at 1 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. And do us a favor, share this show with a friend, rate us on Apple Podcast, go into Overcast and favorite it. And thank you to Fastly, our bandwidth partner. Head to fastly.com to learn more. And we move fast to fix things around here at Changelog because of Rollbar. Check them out at rollbar.com. We're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out and support this show. Our music is produced by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. Thanks for tuning in. We'll see you next week.
I'm Daniel Whitenack.
And I'm Chris Benson. We host Practical AI, a show making artificial intelligence practical, productive, and accessible to everyone.
You'll hear interviews with AI influencers and practitioners, and we'll keep you up to date with the latest news and learning resources so that you can cut through all of the hype.
In terms of environmental sustainability, Microsoft has won numerous awards for that. We've been carbon neutral since 2012. But the way we look at it is, even if Microsoft was absolutely perfect, there's only so much impact Microsoft as a company is having just in our own operations. So how could we scale out even more? AI for Earth was really our answer to that question. By dedicating this $50 million over 5 years, that enables everyone to be able to partake.
New episodes of Practical AI premiere every Monday.
Find the show at changelog.com/practicalai or wherever you listen to your podcasts.